Okay, next question. Simply asks us to find a unit vector which is perpendicular to both u and v. So if we're going to find a unit vector perpendicular to both u and v, we need to find a vector that is first perpendicular to u and v, and then we can take any vector and we can turn it into a unit vector. So let's call the vector that is perpendicular to both u and v a. Okay. How can we find a so that we know that this is going to be perpendicular to both u and v? Not zero, no. There's a particular mathematical operation that always returns a vector perpendicular to the two vectors that you put into it.
Is it the reciprocal?
No. If we just take the cross product, okay? If you take the cross product of two vectors, u and v, you get a vector that is perpendicular to both of these. Okay? It's not the only vector perpendicular to both of these, but it is a vector that is perpendicular to both of them. So to figure out what a is, we want to do u cross v. So we set this up, ijk. We want our u and our v here. So 2, -1, 5, and then 3, 2, 2. And then another copy of I, which is 2 and 3. And we can just go ahead and we can do the cross product here. -3? Oh, thank you. Yeah, -3 there and -3 there. Okay. So if I do this cross product, I end up with -12, -19, and -8. So we've done a bunch of examples of the cross product, so I mean you could verify this yourself if you wanted to. Now the issue is we've got this vector a which is perpendicular to both of these. How can we take this a and turn it into the unit vector a hat? Well, in unit 1, 2, we said that you could take any vector a and turn it into a unit vector by dividing out the magnitude. Okay, so if we take a, divide it by the magnitude of a, we'll get the unit vector a hat. So we need to figure out the magnitude of this vector a. And to do that, we just take each of our components, square them, add them up, and then take the square root. So -12 squared plus -19 squared plus -8 squared. Okay. Oh, and I've done this wrong because this shouldn't work out to be -8. This should work out to be 1. Sorry about that. Okay. So when you were verifying that, you probably thought, hey, what's going on here? But no, so it's supposed to be 1 in there. Okay, so we work all this out. Square root of 506. So our unit vector is going to be 1/506 times our original vector a, which was -12, -19, 1. And we're just multiplying a vector by a scalar, so we multiply each of our components by the scalar that we have out front, and we get the vector 12/506, comma 19, -19/506, and 1/506. Okay, and that is our final, that is our unit vector. We could work this out. We would find that it has a magnitude of 1, and again, the relative sizes of the x, y, and z components tells us all of the directional information.